Hello friends, welcome to my channel. This is the series of theory of competition for a gate short note practice. Is Fastly we practice all the concepts of theory of competition. So let's start. The first topic is the finite state automata. In this, we have two type of machines or automatas. First is a finite automata with output, and next one is finite automata without output. So finite automata with output, which is mainly in two parts, Moore machine and Miller machine. But we generally rarely use or rarely one or two questions are put in the gate examination previously. So we full focuses on the finite automata without output. So in this we have learned three machines, DFA and NFA and epsilon NFA. You know the full forms of these three machine: deterministic finite automata, non-deterministic finite automata, and epsilon NFA. So let us move and brief introduction about the DFA, deterministic finite automata. In this, we all know about there are five tuples, which is generally same in all the machines. But we look at these tuples. You know what about the Q set of all state, and what about the epsilon? This is the epsilon is for inputs. That means how, in fact, how much number of states, that means what number of inputs are given. That means A or B or C. That means A produce 1, also 0. So inputs are 1 or 0. We can say that let us assume A produced three inputs, X, Y, and also Z. Then we write it here, X, Y, and Z. So this is the all the things. And Q naught, we know that where the our machine produce the inputs, so that is known as the our Q naught. That means start state, and set of final state. That means here here I create D is a final state. So generally in questions, one final state, but we generally in the question one finite state. But all another machines, we have looked into the machines, one, two, or three finite states are available. So here we write it, D, B, C are the finite states, etc., etc. And this is the transition function from Q into epsilon into Q. So this is the very simplest automata, we can say, in the theory of computation method, because this is the theory. These machines are available before our computer is not generated, or computer is not made. That time we how calculate the data, how calculate, how run the program on the machines that time. So this is the theory computation. And look at the definition in the DFA. Given current state, we know that what will the next state. Here only there are no same data when we produce. There are no same data. Here are A is produce, here are produce input A to B is 1, then A to C is 0. So there are not be in DFA is 1 or 1. So these things are in DFA. When we have different or unique state, there are unique state, that is called the DFA machines. So look at the so this is the table, transition table. In this table we have look when we when input our state A produce a 0 input, then where our data is go, where our data is C, state C. So here I write C, as well as when our A is produced 1, then where our data is go to state B. So like that, these all the things are arranged. And you have also seen that there are no same data are available. So let us solve a question. This question generally asked in university exam as well as in gate exam. We have written language set represent at L when I am considering set of all strings that start with 0. Set of all string that will start with 0, and the language of this machine, this is the language, sorry, and this is the regular expression for the machine. uh, Question says set of all strings that start only with 0. So 0 0 0 0 1 0 0 0 0 1 0 0 1 0 0 0 0 and 1 or 0 0 0 0 etc etc and so on. So look at the machine. First thing I will clear to you, whenever a machine is create or initial state, then there are possibilities of two inputs. There are possibilities of two inputs that are generated from A to B or A to C or A to B. In NFA is we can also produce two inputs in the on the to the same to the single state. So in but we talk about the DFA and solve the DFA example. So look at it, the DFA. In the DFA we have produced A to B, that is 0, okay, and make B is a final state and create a self loop 0 and 1. And so what is this, let us check. We have I have also says that there are two inputs 0 and maybe possibilities of 0 is accepted or 1 is possible. A is accepted, B is accepted, X is accepted, Y is accepted. So we also check that one, maybe 1 is accepted, but we create 1 and create a new state C, and we also create a 0 and 1 loop because we have infinite set of uh, infinite set of regularization or language according to our question. Example, let us take and check the machine. We have check 001. When we give to the 001 to this machine, let us run. When 0 is 0, then this is not is come, A is produce 0, so A going to B. And here again is 0, okay, no problem, we create a self loop and this is very easily, and then 1, okay, this is successfully run. Okay, let us another example, 101. So in this we 1, but one second, we check is because why we check this, because set of all string that start with 0, so this is not in present in our language. So example 101, so 1 and 0 and 1. So this, but this is not a final state, that is it is called a dead state, or also it is called a trap state, because C is a dead state, that will it is not applicable. So I hope this is clear, you all the clear the concept of a DFA machine. So let us move to the NFA machine and look at example with NFA machine. In NFA machine, in NFA, given the current state, there could be multiple next state. I will also say that the next state may be chosen at random. We send A to B is 1, A to C is 0, so A to D is 1 and A to E is epsilon also. So I will explain you what is epsilon. Epsilon is nothing but that is the empty, that is the empty set. Okay, so A to B it go input is 1 and A to D is also going to input in, but in DFA that is not applicable. So in NFA that is right. So epsilon comes only in NFA, that is the most important point. Epsilon, whenever epsilon comes in your machine, that will you will easily say that that is the machine is called NFA. So here is a set of all string end with 0. We previously solved that set of all string start with 0, and here we can here we solve that set of all string end with 0. So A, we when we give to the input, let us example, let us check the machine our. So in this what do we say, that set of all string end with 0, okay. So 1 0 0 1 0, okay. सो एक और एग्जांपल ले लेते हैं जिसमें हमारा 0 से एंड नहीं होगा, 0 0 1 1, ओके. सो लेट अस चेक व्हाट इज द रॉन्ग, व्हाट इज द राइट एंड व्हाट इज द रॉन्ग. So here we can 1 minute. Let us check this these example in the machine and run the program. So one, okay, easily we can, but our cursor is in one, and zero, zero, and one and zero. So zero and zero and like 1 minute, one, zero, zero, one, and zero. That is we easily run. So because it run because it end with zero according to our question. So uh, try this. Zero, zero, one, one. So zero and again 0 and again 1 and again 1. So that is, but here a, that is, it is not a finite state, so that it is not applicable in this. Previously we can say that there are five table, we can where I also say that they are generally same in all the machines. Some machines are different, like a Melee and More machine, so we can say that in further videos. So there are five table set of all states, you know easily, and but there is a small difference. 2 to the power q is the transition function. So look at some examples or generator machines. You can also practice these questions. So example one is says that when we a to b, we generate a machine, and let us take the example 100 and run the machine. So this machine example I elaborate or explain this machine, take explained or expand this machine. So one is give to the input, and again zero, so again zero input. We have to and again zero, this is one and zero. Then a come to the here is our cursor is a, at a, and a go to the a or b. So what is the our next 10, and that is 0. So go to the final state, because going to the a state and then 0. So 1 0 0 and a to b. So here is our set is accepted. If here is a, if there is any way to run the machine that ends in any set of state out of which at least one state is a finite state, then the NFA accept. So these are all about the NFAs. I have also explained all the topics related to the NFA. So stay tuned. Goodbye. Tata.